Okay, in this video, we're going to have a look at solid-state storage. Cambridge says you need to be able to describe the operation of solid-state storage. So basically, we need to talk about what it is, how it works, where you might find it, and some good and bad points about it. So let's start off with looking at matter. Okay, a little bit of physics for you to start off with. Not too much though. So all atoms are comprised of electrons in motion around a nucleus. Electrons are very small particles, and an electric current is a flow of electrons. A material that doesn't normally allow electrons to flow through them is called an insulator. Now, I just want to focus on these last 2 points because these are really important for our technology, our solid-state technology. An electric current is a flow of electrons. Okay, a material that doesn't normally let electrons flow through it is called an insulator. So solid-state drive, and we'll get into this in more closely in a second, it basically is an insulator. An SSD is an insulator. And we use it to trap electrons. And then we can use that, and we're going to talk about it in a second, to represent computer memory or computer data inside of the memory. So let's see how it works. So we have our solid-state drive. And as I said before, it works by trapping electrons. So we do this by sending a flash of electricity that forces electrons through an insulator. When the electricity stops, the electrons are stuck there. Okay, so we're forcing electricity through. When we stop the electricity, the electrons are stuck where we've put them. Now, the memory device can detect stuck electrons, and it will, if it detects a stuck electron, it will represent it as a 0. If it doesn't detect stuck electrons, it will represent it as a 1. Okay, so if there's electrons in there, 0. If there's not, 1. So let's have a look at how we actually read and write to these devices. So as we said before, a flash of electricity will put the electrons into place. Now they will stay there even if the machine's unplugged, even if you've got a laptop and it runs out of battery, even if you drop your phone and it breaks, the electrons will stay in your solid-state drive. Now, if we want to remove it, we need to send a flash of electricity the reverse direction, and this will free the trapped electrons. So if we just draw a little simplified diagram here, if we use this as flash storage, and if we want to put something on the storage, we force electricity through, and it will put electrons in there, and they can be read by the storage device to see if there's something there or not. If we want to remove the electrons, we put a flash of electricity the other way, which will wipe them out, and then again it can be read by the storage device to read if there's electrons there or not. So that is how we read, write, and erase from flash storage. Okay, let's have a look at the different types. Now, you will commonly see this type of technology take on 2 names: solid state and flash memory, and this is why. We use solid state because the actual storage device itself is a solid structure. Okay, the insulator that it's stored in is a solid structure. There's no moving parts like in an optical disc that spins or magnetic drive that spins. It doesn't have that. It just stays still. And you'll see it called flash memory because it uses a flash of electricity to set the electrons in place. Now, the ones we need to know about, or the devices we need to know about, are USB storage, solid-state drives, and mobile devices. So let's have a look at USBs first. Look like that. They take on many shapes and sizes, lots of different capacities, but they all look like this. So I want to draw your attention to this piece here. This piece here is the USB technology. If you can't remember about USBs, you can watch the video about USBs I did earlier on in the course. And this is a connector. This is not the memory device. This is a connector. This is the storage device here. Underneath this casing, that's the storage. This is a storage device that uses USB to connect to a computer. That's what it is. The USB has nothing to do with storage. It's a connection. This here is a connection. Okay? Well, let's have a little closer look. So like I just said, USB is a type of connector. Don't make that mistake in your exam. It's a connector, okay? Now, the USB flash drive is flash memory with a USB plug. So there's actually two types of technology here. We have our USB connection technology and our actual storage technology here. Two types of technology being used. Now, it's convenient. Obviously, we know how convenient these are because we can just stick them in a computer and they work, no problem. Very easy to carry around, can be incredibly high storage in a really small device. So all of these things make it really good and convenient to use for students, for professionals, for pretty much anyone. And they're very common. Yeah, you see these for sale in newsagents and everything. Let's have a look at solid state drives. Now, solid state drives kind of look like this. Again, they come in different physical and memory sizes, but they all kind of look like this, and SanDisk is a very popular brand. What are they? So, a solid state drive, solid state drive is a large piece of solid state fixed inside of a computer. So these are inside of your machine, okay? SSD tend to be inside. You can get external ones, but more often than not, you'll be looking at it inside of your computer. Now, flash memory is instead of the hard disk drive, the magnetic disk drive. If you can't remember a magnetic disk drive, you can watch the magnetic disk drive video. But normally it's replaced. Some machines might have a solid state and a magnetic, but it's not very common. So it's normally your flash memory will be replaced by that. Now, solid state is reliable. It's a lot lighter than magnetic, and it has a high storage capacity. All good things for a machine. The thing is with it though, it's more expensive, which will make your computer cost more. All right, let's have a look at mobile devices. So mobile devices like smartphones, iPhones, Samsung Galaxies, things like that, and tablets like iPads, all use solid state storage. This is because it's very small, it has no moving parts, and it's very light. That means we can hold a lot of data and make something very light and portable. We would not have modern day mobile devices without SSDs. Right? It just wouldn't be possible. They would get too hot, they would be too heavy, they would be too big. We need SSD for modern day mobile devices. So let's have a look at some advantages and disadvantages just to finish off. So it is very popular. It's a very popular choice of storage. It's not always the best choice. If you get an exam question, please make sure you think about how much storage you need, how much money you have, who will be using it, etc., etc. But you can watch the video about choosing what type of technology to use if you can't remember that. So some advantages of SSD. It's small, light, and strong. I've had pen drives that I've put through the washing machine and all sorts, and they've been fine. The reason they've been put through the washing machine is because they're so small. I didn't realize they were in my pocket. It can store a lot of data, and it's very easy to erase and rewrite on things. It does it quite easily, and that is what we need for a personal computer or professional computer to be able to store things. Some disadvantage, the big one is it's expensive. Things always come down to cost. If something's more expensive, that is never a good thing. And there are some slight concerns about how long it will hold. So where if you look at magnetic storage, magnetic tape, magnetic hard drives, they are time tested and they've been around for a long time, and we know data will stay there. This is a newer technology, so there is a little bit of concern, not a massive amount, of how long it could keep the data. Okay, and that is everything. I will try and zoom out here, see if I can fit it all in so you can take a screenshot if you want to. It might be a little bit too small for you though, but if you can, or you can see it, take a screenshot.